Good evening, everyone. Moving forward, our next session explores edge computing for 5G and 6G, a technology that is reshaping the landscape of connectivity, efficiency, and real time processing in modern networks. It's a great honor to introduce our distinguished resource person, Mr. Ram Shairam Durai, as a seasoned R&D engineer at Hitachi Energy Technology Services Private Limited, Chennai. He brings with him an impressive 10 years of industrial experience in the electronics domain. His expertise spans designing, developing, and optimizing embedded systems for diverse industries with a special focus on embedded firmware development, system architecture, and hardware software integration. Notably, he has made significant contributions to the development of battery management system BMS for electrical vehicles, showcasing his commitment to innovation and sustainability. His leadership skills and ability to manage complex projects have earned him a reputation as a collaborative and results driven professional. Throughout his career, he has demonstrated a passion for mentoring and guiding junior engineers, fostering a culture of collaboration and innovation. His dedication to delivering high quality solutions, meeting product requirements, and maintaining exceptional standards of quality and reliability is truly commendable. Today, we are privileged to have Mr. Shairam Durai with us, and we look forward to his insightful address. Now, I am handing over the session to our resource person. Please, sir.
Yeah, thank you. Thanks for the quick intro. I hope my voice is audible, right?
Yes, sir. Your voice is clear.
Yeah, okay. What about my PPT screen? Is
It
it
is also
visible?
visible, sir.
Yeah, okay. Thank you. Okay. Good evening, everyone. My name is Ram Shairam Durai, and I'm currently working as a R&D engineer at Hitachi Energy Technologies Private Limited, specializing in HVDC technologies like high voltage direct current. And I have a strong background in embedded software development with extensive experience in designing, implementing embedded systems and hardware products. Throughout my career, I have worked in various communication protocols and designed various control boards and developed software for embedded devices. Okay, I'm excited to share my knowledge and insights on edge computing in 5G, 6G networks with you today. Let's explore how this technology can transform various sectors and improve our daily lives. Okay, yeah. So here's the agenda for today's presentation. We will start with an introduction to edge computing, followed by a discussion on the shift from cloud to edge computing. We will then cover the importance of low latency, the increasing in data generation, and the need for reliable real-time processing. Next, we will explore the role of 5G, 6G in edge computing, then compare the reduce latency and discuss the bandwidth efficiency as well. Then we'll also see the enhanced security and privacy. Then how we can scale the edge computing and provides real-time decision-making examples. Finally, we will delve into specific use cases, including traffic collision avoidance, smart cities, then industrial IoT like 4.0, then precision farming, telemedicines, and emergency responses as well. And next slide. Okay. Introduction to edge computing. Edge computing refers to a practice of processing data near to the source of data generation rather than relying on a centralized cloud. Like this approach brings computation and data storage closer to the devices where it's being gathered, which improves response times and saves bandwidth. Like edge computing is essential for a application requiring a real-time data processing, okay, such as autonomous vehicles, smart cities, industrial automations. By processing the data locally, edge computing reduces the latency and enhances the security and enables the real-time decision making. This shift is crucial as we move towards a more connected and a data-driven world, like where the speed and efficiency of data processing can significantly impact various industries and applications. Okay. Now shift from cloud to edge computing. Like in a traditional cloud computing has been a backbone of data processing and storage of storage for many years. In this model, data is sent from devices to centralized centers where it is processed and stored. While this approach has its benefits, such as centralized management and scalability, it also comes with several limitations. They are becoming increasingly apparent as the number of connected devices grows, right? The problem also will create. Like one of the primary limitations of traditional cloud computing is high latency. When the data travels long distance to reach the centralized servers, there is an inherent delay in processing and response times. This latency can be problematic for applications that require real-time data processing and immediate decision making, like in our case, like such as autonomous vehicles or industrial automations. The bandwidth constraints are another significant challenge, as the number of IoT devices and volume of data they generate continue to increase. The demand for bandwidth grows like exponentially. Transmitting like large volume of data to centralized servers can strain the network resources, leading to like network traffic congestion, and it will gradually reduce the performance. Then security and privacy concerns also arise with the traditional cloud computing. Transmitting sensitive data over a long distance increase the risk of data breaches and unauthorized access. Additionally, like data regulations require that certain types of data remain with a specific geographic boundaries. The complicating the data management for global organization, right? Edge computing address these challenges by adopting the decentralized approach. Like instead of sending all data to centralized data centers, edge computing process data at edge of the network, close to where it gets generated. This shift offers several key benefits. Like it will reduce the latency, like by processing the data locally, edge computing minimizes the delay between the data generation and processing. This is the crucial for applications where every milliseconds counts, like such as autonomous driving and real-time analytics, right? If any delay in a millisecond, right, it will tends to serious safety as well as the health hazards. Then improved bandwidth efficiency, like local data processing reduce the need of transmit large volume of data to centralized servers and conserving bandwidth and reducing the network congestion. Then it will increase the security as well, like processing sensitive data locally reduce the risk of data breaches during transmission and ensure the compliance with the data protection regulations. It depends upon the geographic conditions. Then real-time processing capabilities, like edge computing enables real-time data processing and decision making, which is essential for applications that require immediate response. Like for example, in industrial automation, the real-time monitoring and control of machinery can prevent equipment failures and reduce the downtime. Okay, we'll go for next slide. Okay, then importance of low latency. Right, in the slide also you can see the LTE, then it will compare with 5G. Like it takes like 125 milliseconds, and here it's like 4 milliseconds. It's a huge difference. Like latency refers to the delay before transfer of data begins following an instruction. Like in the context of data processing and communication, it is a time taken for data to travel from its source to its destination and back. So low latency is crucial for many modern applications that require real-time data processing. Like in augmented reality also, right? The data has to process very fast without any latency. Okay, then it's plays a huge role in like autonomous vehicles. Like let's say autonomous vehicles rely on real-time data from sensors and cameras to make split-second decisions, right? Low latency ensures that the vehicles can process this data quickly and respond immediately to changing the road conditions. It depends upon the road conditions, obstacles, and other vehicles, right? Any delay in data processing could result in accidents or unsafe driving conditions. Then if we take augmented reality also, as I discussed earlier, low latency is essential to ensure that the virtual environment responds instantaneously to user movements and actions. High latency can cause motion sickness, like, and disrupt the user experience. Then in real-time analytics also, like in industries such as finance and healthcare, right? The real-time analytics are used to monitor and analyze the data as it's generated. Low latency enables immediate insights and actions, allowing organizations to respond quickly in emerging trends and anomalies issues. For example, let's say in financial trading, low latency can make the difference between the profitable trade and the missed opportunities, kind of stuff. Then if you take telemedicines, like telemedicines involves a remote diagnosis and treatment of patients using telemedicine technology. Low latency is crucial for real-time video consultations, like remote monitoring of vital signs and timely medical interventions. So here, edge computing plays a key role in achieving low latency by processing data locally close to the source of data generation. This minimizes the distance as to travel. Next. Then increasing in data generation. In this graph, you can see, right, over the times of year, right, uh, the the data generation is like grows exponentially. Okay, so the rapid growth in the number of connected device, particularly like Internet of Things devices, is generating vast amount of data at an unprecedented rate. This phenomena, often referred to as a data explosion, is transforming various industries and creating new opportunities and challenges. Let's delve into deeper into the factors driving this increase in data generation and its implications. Like IoT devices are embedded with sensors, softwares, and connected capabilities, enabling them to collect and exchange the data. These devices ranges from smart home appliances and wearable fitness trackers to industrial sensors and connected vehicles. Like it expected, like by 2025, it is estimated that there will be a 75 million IoT devices in worldwide, each generating continuous stream of data. The sheer volume of data generated by IoT device is staggering, and this data includes everything from like temperature and humidity readings to video footage, location data, and machine performance metrics. As more devices come online and the existing devices become more sophisticated, and the amount of data like being produced continuously grow exponentially. So what are the challenges? Like the traditional cloud infrastructure, which relies on centralized data centers, struggle to handle this data, like deliver efficiently. Transmitting large volume of data to centralized servers can lead to already discussed like network congestions, increasing latency and higher cost. Additionally, the centralized model may not be able to scale effectively to accommodate the growing number of connected devices and data they generate. And one more thing, like bandwidth constraints also they play a huge role. Like as a volume of data increases, so does the demand for bandwidth, and transmitting vast amount of data over the network can strain the bandwidth resources, leading to slower data transfer rates and reduced performance. Like this is particularly problematic for applications that require real-time data processing and immediate responses. Okay. Then edge computing address these challenges by processing data locally close to the source and generation. Like so, it will reduce the latency, bandwidth efficiency. Then you can scale also. The most of the computational it takes place in the edge device, so we can scale as much we can, and it will increase the security also. So as the number of connected devices continues to grow, the ability of process the data at the edge become increasingly important for maintaining efficient and responsive systems. Edge computing address the limitation of traditional cloud infrastructure by enabling local data processing, ensure that applications remain performs and reliable. Okay, next slide. Now, need for reliable real-time processing. Like in our case, like real-time processing refers to the ability to process data as is generated without any significant delay. This is in contrast to batch processing, where data is collected over a period and processed at a later time. These are like reliable real-time processing ensure that data is processed accurately and consistently, providing a timely insights and actions. Like as we discussed, like autonomous vehicle rely on a real-time data from sensors, cameras, and other devices to navigate and make the decisions. So reliable real-time processing is crucial for interpreting this data and responding to dynamic road conditions. Then in industrial automation also, like real-time monitoring and control of machinery and process are essential for maintaining operational efficiency and preventing equipment failures. Like sensors and machinery collect data parameters like such as temperature, pressure, vibration, and so on. Like reliable real-time processing ensures that this data analyzed properly, allowing for immediate corrective actions to prevent the downtime and improve the productivity. Like one more case, like in smart grid, let's take smart grid. Smart grid uses real-time data to manage energy distribution efficiently, like the to monitor the energy consumption and detection of anomalies and adjustment of supply to meet the demand dynamically, right? This we need real-time data. Then in financial service also, like real-time processing is essential for accurately plot the data and to evaluate the risk management. And financial transactions generate vast amount of data that need to be processed in real time to identify the trends and detect the fraudulent activities and make the informed trading decisions, all the stuff. So by using edge computing, that we can make timely decision making, like reliable real-time processing enables the organization to make the informed decisions quickly based on the most current data. And the operational efficiency also, like real-time processing ensures that the machinery operates efficiently, that without any issues are addressed properly. And in many sectors, like customer satisfaction also one of the key factors, like real-time processing improve the customer satisfaction by enabling the quick and accurate transaction and personalized services and a timely response to the customer inquiries. Okay, next slide. Okay, now role of 5G and 6G in edge computing. Like 5G and 6G networks are revolutionizing the way we connect and interact with technology. Like they play a major role in the advancement of edge computing. These next generation networks like provide the necessary infrastructure to support the real-time data processing and communications, like enabling a wide range of applications that requires low latency, high reliability, and massive connectivity. Like let's explore the key aspects of 5G and 6G networks and the impact of edge computing. Like in 5G, one feature is there, like ultra reliable, low latency communications. Like one of the most significant features of 5G and 6G networks is their ability to provide ultra reliable low latency communications. This means the data can be transmitted with minimal delay and high reliability, which is like crucial for applications that require real-time responses, and ensure the data from sensors and cameras is processed and acted upon immediately, like enhancing the safety and performance. And one more feature is have like enhanced mobile broadband. Like enhanced mobile broadband is another key features of 5G and 6G networks. It provides high-speed data transfer rates, enabling seamless streaming of high-definition video, virtual reality, and augmented reality applications. In the context of edge computing, EMBB allows for rapid transfer of large volume of data between the devices and edge servers, facilitating the real-time data processing and analysis. Then it's having massive machine type communication. Like massive machine type communication refers to the ability of 5G and 6G networks to connect a large number of devices simultaneously. This is particularly important for Internet of Things, where billions of devices like generate continuous stream of data, ensure that these devices can communicate efficiently and reliably, supporting the scalability of edge computing solution as well. Then the integration of 5G and 6G networks with the edge computing creates a powerful synergy that enhances the capabilities of both technologies. Like by bringing computation close to the data source, edge computing reduces the latency and improves the efficiency of data processing. So 5G and 6G networks play a crucial role to bring down the latency, and it will increase the high speed as well to support the decentralized approach. The combination of 5G and 6G and edge computing enable the wide range of real-time applications. For example, like smart cities, real-time monitoring of traffic, energy usage, and public safety can be achieved through seamless integration of edge computing. In industrial settings, like the integration of 5G and 6G and edge computing supports real-time monitoring and the control of manufacturing process. Like sensors and machinery can collect and performance the metrics, which then process locally at the edge. Next one, next slide. Okay, so reduced latency comparison. Here you can see the chart, the speed of over the generation signals like 1G, 2G, 3G, 4G, and 5G. Now we are running in 6G. Like the traditional cloud computing involves higher latency due to the data traveling to and from centralized servers. This can result in delay in several hundred milliseconds. In contrast, the edge computing process data locally, significantly reduce the latency in just few milliseconds. For example, in smart city application, the data from sensors can be processed at the edge to provide the real-time insights and actions. Bandwidth efficiency. Here you can see the higher the bandwidth, right? We can accommodate huge data like high volume of data. Like edge computing reduces the need to transmit a large volume of data to centralized servers, conserving the bandwidth and processing the data locally. Like edge computing makes the bandwidth available for other critical applications. For instance, in video surveillance, processing data at the edge reduces the need to send high definition video streams to the cloud, saving the bandwidth and enabling the real-time analysis. The bandwidth efficiency is particularly important as the number of connected devices continues to grow. By reducing the like amount of data that needs to be transmitted, like edge computing helps to uh, reduce the network congestion and improve the overall system performance. Now, like enhanced security and privacy. Now we are in a like 2020, in mid of 2030 and 2020. Uh, Processing sensitive data locally at the edge reduces the risk of data breaches during the transmission. This approach ensures the data remains within the local jurisdiction, complying with the data protection regulations. For example, in healthcare, the processing patient data at the edge ensures the privacy and compliance with the local regulations, like in the local body regulations. By minimizing the data transmission, edge computing enhances the security and privacy, making it is a preferred choice for an application that handle sensitive information. This enhanced security is crucial for maintaining the trust and confidence of the users, particularly in applications that involve personal or confidential data. Okay. Next, scalability of edge computing. Edge computing allows for a scalable and distributed data processing, accommodating the growing number of IoT devices. The data they generate in smart cities, for example, thousands of sensors. Like in our previous project, we have worked on Nashik smart city and all. And the device generate vast amount of data. They need to be processed in the real time. And edge computing enable this efficient local processing, ensure that the system can scale to handle the increasing the load, data load, and the scalability is essential for supporting the continued growth of IoT and other connected technologies. By distributed the data processing across multiple edge devices, we can ensure the systems remain responsive and efficient, and even as a number of connected devices continues to grow in the future. Next slide, like real-time decision-making examples. Like edge computing enables real-time decision making in various applications. For instance, in traffic collision avoidance, edge computing collects position and dynamic information of vehicles and predict the possible collisions and send warning signals to the vehicles in danger, such as smart traffic lights and waste management systems. In industrial IoT, then telemedicines and remote diagnostics, responsive emergency response enhancements, then smart grids in power industries as well. We'll go one by one in the upcoming slides. Here you can see like traffic collisions avoidance use case. The vehicular edge computing collects positional and dynamic information of vehicles to predict the possible collisions and send warning signals to vehicle in danger. Like this real-time data processing is crucial for preventing accidents and ensuring the road safety. Like 5G, 6G networks provide the necessary low latency communication for real-time warnings, enabling the vehicles to respond promptly to potential hazards. This use case demonstrates the importance of edge computing and 5G and 6G integration in enhancing the transportation safety as well. By processing the data locally, we can ensure that critical decisions are made in real time and improving the safety and efficiency of transportation systems. Next one, like smart city applications. Like smart cities leverage advanced technologies to enhance the quality of life for residents, improve the urban infrastructure, and ensure the sustainable development. Secure edge network plays a crucial role in supporting various applications within the smart cities, enabling real-time data processing and decision making. Let's see one by one. Like if you take like unmanned aerial vehicles based systems like UAVs, we call it, commonly known as drones, are used for various applications, including surveillance, delivery, and environmental monitoring. In smart cities, UAVs can monitor traffic conditions, inspect infrastructure, and deliver medical supplies. In many countries, they are implemented. For instance, drones equipped with cameras can provide a real-time aerial views of traffic congestion and enabling traffic management systems to adjust the signals and routes dynamically. Then real-time monitoring and management, like if you take urban infrastructure such as bridges, roads, and buildings, ensure timely maintenance and reduces the risk of failures. Sensors embedded in the infrastructure, right, can detect the structural issues and send alerts for immediate actions. Like additionally, the surveillance cameras and sensors can monitor public spaces for safety and security. Real-time data from these devices can help law enforcement and respond quickly to incidents and manage crowds during the events. Then waste management system also, like smart waste management system uses sensors to monitor the fill of waste bins, like the dustbins, and optimize the collection routes. This reduces the operational cost and minimize the environmental impact and ensure the timely waste collections. For example, in a smart city, waste bins are equipped with sensors and can send data to centralized system, which then schedule the collection based on real-time fill levels. This prevent overflowing bins and reduce the unnecessary collection trips. Then environmental monitoring, like sensors can monitor the air quality in real time and providing the data to address the pollutions and improve the public health. Like smart water management systems can monitor the water quality and detect leaks in real time and ensuring a safe and reliable water supply. These systems helps cities maintain a healthy environment for the residents. And like for engaging the citizens, like mobile applications can provide us residents with the real-time information about the city services, events, and emergencies. These apps can facilitate communication between the residents and city officials. For example, a smart city app can notify the residents about the road closures, public transportation schedules, and community events. It can allow the residents to report the issues such as potholes and streetlight outages directly to the relevant authorities. Yeah, and next, industrial IoT task offloading. Like industrial IoT is a revolutionizing the way industries operate by connecting the machines, sensors, and devices to the network, enabling the real-time data collection and analysis. Like one of the key components of industrial IoT is task offloading, which involves transferring like the computational task from local devices to edge servers. This process optimizes the energy consumptions and enhances the processing efficiency as well, leading to significant improvements in industrial operations. Task offloading allows the industries to offload the resources like intensive tasks to edge servers, which are equipped with greater computational power. This reduces the burden on local devices, ensuring the operation efficiently without overheating and consuming excessive energy. So, by offloading the task, industries can achieve faster data processing and analytics and enabling the real-time decision making. This is particularly important in environment where timely responses are critical, such as manufacturing and logistics. Then, like the real-time monitoring and control of industrial process are essential for maintaining the operational efficiency and preventing the equipment failures. Sensors and devices continuously collect the data on various parameters such as temperature, pressure, and vibration. And in our case, like for implementing the digital twin also, right, the edge computing plays a crucial role. Like it processing the data locally and providing the immediate insights and enabling the quick responses to the anomalies. For example, the sensor detects the abnormal increase in temperature. The edge server can trigger the alert and initiate the corrective actions to prevent the equipment damage. Nowadays in many industries they are going with like predictive maintenance is a proactive approach that uses the data analytics to predict when the equipment is likely to fail, allowing for timely repairs and maintenance. This approach minimizes unplanned downtime and extends the lifespan of machinery. Edge computing plays a crucial role in predictive maintenance by analyzing the data from sensors in real time. For instance, the vibration sensors on motor can detect the early signs of wear and tear, and the edge server process this data and predicts when the motor is likely to fail, allowing maintenance teams to schedule a repair before the breakdown occurs. And it will contribute to energy optimization as well. Like task offloading to edge servers helps optimizing the energy consumption by reducing the workload on local devices. Is particularly important in industrial settings where energy cost can be significant. By processing the data at the edge, industries can also reduce the amount of data transmitted to centralized cloud servers, conserving the bandwidth and further reducing the energy consumption. Okay, next slide. Precision farming in agriculture. Like precision farming, also known as the precision agriculture, is a modern farming practices that uses advanced technologies to optimize agriculture process and increase the crop yields by leveraging the real-time data and analytics. Precision farming enables the farmers to make informed decisions about their crops, soils, and resources. Like edge computing plays a crucial role in this process by providing the necessary infrastructure for the real-time data processing and decision making. Like let's explore the key aspects of precision farming and how edge computing enhances effectiveness. Precision farming relies on real-time monitoring of various factors such as soil conditions, crop health, and weather pattern as well, and irrigation levels. Sensors placed in the fields collect the data on soil moisture, temperature, and nutrition level also, and other critical parameters. Drone equipped with the cameras and sensors can capture the aerial images of the fields and providing the insights into the crop health and growth patterns. The data collected from the sensors and drone is processed locally at the edge, allowing for immediate analysis and insights. Edge computing enables the processing of large volume of data in real time and providing farmers with actionable information. For example, if the sensor detect low moisture levels, the edge servers can trigger the irrigation system to water the crops and ensure the optimal growth conditions. By analyzing the real-time data, like the precision farming helps optimize various farming practices. Farmers can adjust the irrigation schedules, apply fertilizers more efficiently, and monitor crop health to prevent diseases and pests. This data-driven approach improves the productivity and sustainability in agriculture. For instance, the precise application of fertilizers based on soil nutrition level reduce the waste and minimizing the environmental impact. So precision farming technique leads to increase in crop yields by ensuring the crop receives the right amount of water, nutrition, and care at the right time. Real-time monitoring and the data analysis is enables the farmers to identify and address the issue properly. preventing the crop loss and maximize the yields. For example, early detection of pest infestation like the insects attacks, right? Through drone image, allow for targeted pest control measures and protecting the crops and ensuring the healthy growth. Then it also use the resources such as water and fertilizers, pesticides by applying these resources where and when they are needed. Like farmers can reduce the cost and minimize the environmental impact. Edge computing facilitates this efficiency by providing the real-time data and insights, enabling the precise and targeted interventions. So it will increase a lot of sustainable farming practices are essential for preserving the natural resources and ensuring the long-term agricultural productivity. Precision farming supports sustainability by reducing the resource wastage, minimizing the chemical runoff, and promoting the soil health. So it depends upon the climate, right? Precision farming helps farmers adapt to change the climate conditions by providing the real-time data on weather patterns and soil conditions. This information allows farmers to make informed decisions about planting and harvesting times. Yeah, next slide. Okay. If you take a look at telemedicine and remote diagnosis, telemedicine and remote diagnostics enable the continuous monitoring of patient health and allow healthcare providers to diagnose and treat patients remotely. Like edge computing ensure low latency data processing for timely medical interventions. For example, wearable devices can monitor patient vital signs in real time and alerting the healthcare providers to any abnormalities. This real-time monitoring improve the patient outcomes and make healthcare more accessible, especially in remote areas. By processing the data at the edge, healthcare providers can deliver timely and effective care and reducing the need for hospital visits and improve the overall patient satisfaction. Yeah, then you can see like emergency response enhancements. Real-time data processing enhances the responsive times and decision making in emergency situations. Like applications include disaster management, let's say, public safety and emergency medical services. For example, the real-time data from sensors can provide a situational awareness during the natural disaster, enabling the emergency response to allocate the resources more effectively. Edge computing providing the necessary infrastructure for the real-time situation awareness and improving the effectiveness of emergency response. By processing the data locally, edge computing ensures the emergency response receives timely and accurate information. Sorry. Next slide. Yeah. Here you can see like smart manufacturing process. Smart manufacturing is revolutionizing in the way the industries operate by integrating advanced technologies to enhance the efficiency and productivity and flexibility. Like at the heart of smart manufacturing is the concept of real-time monitoring and control, which is made possible through edge computing. Let's explore the key aspects of smart manufacturing process and how edge computing plays a crucial role in the transformation. In smart manufacturing, like the real-time monitoring involves continuously tracking the performance and conditions of machinery and production lines. Sensors embedded in the equipment collect the data on various parameters such as temperature, pressure, vibration, and operational speed. This data is processed locally at the edge and allowing for immediate analysis and insights. Like the real-time control refers to the ability to make instant adjustment to the manufacturing process based on the data collected. For example, if the sensor detects anomaly in machine operations, the edge server can trigger immediate response, such as adjusting the machine settings or shutting it down to prevent the damage. Then by enabling the real-time monitoring and control, the edge computing significantly improves the operational efficiency in manufacturing. It allows for proactive maintenance where the potential issues are identified and addressed before they lead to the equipment failures. Additionally, the real-time data analysis helps to optimize the production process. For instance, by monitoring the performance of different machines, manufacturer can identify the bottlenecks and implement the changes to streamline the workflows. This leads to increased productivity and reduce the operational cost. Then it will increase the product quality as well. Like smart manufacturing process ensure the consistent product quality by continuously monitoring the production parameters and making the necessary adjustments in real time. For example, in a food processing plant, a sensor can monitor temperature and humidity levels to ensure that the products are processed under optimal conditions. Any deviations from the set parameters can corrected immediately, maintaining the high product quality. Then edge computing enables manufacturers to implement quality control measures at every stages of the production. This reduces the likelihood of defects and ensure the finished product meet the required standards. And it will also increase the flexibility and adaptability. Smart manufacturing processes are highly flexible and adaptable, allowing the manufacturer to respond quickly to changing the market demands. Like edge computing enables the real-time adjustment to production schedules, inventory management, and supply chain operation as well. For instance, if there is a like sudden increase in demand for a particular product, let's say, and manufacturers can quickly ramp up the production by reallocating the resources and optimizing the workflows. The flexibility ensures that the manufacturers can meet the customer demands efficiently. So it also increases the energy efficiency as well. Like edge computing helps optimize the energy consumption in manufacturing process by monitoring the energy usage in real time. Manufacturers can identify the areas where energy being wasted and implement measures to reduce the consumption as well. Like this not only lowers the operational cost, but also support the sustainability initiatives. For example, by analyzing the data on energy usage, the manufacturers can adjust the machine settings to operate at optimal efficiency, reducing the energy consumption without compromising the productivity. So we can make the like data-driven decision making to enhance the operational efficiency and productivity. Edge computing provides the necessary infrastructure for real-time data processing and analysis. Okay. Next slide. Like the smart grids in a power industry is one of the applications. Like smart grids use a real-time energy management to monitor and manage energy distribution in real time. Like edge computing optimizes the energy usage and reduces the outages for by processing the data locally. For example, the real-time monitoring can detect the fluctuations in the energy demand and adjust the supply accordingly, ensuring the stable and efficient energy distribution. This approach not only improves the reliability of power grid, but also enhance the energy efficiency and sustainability. Yeah, just told. Next, the future advancement in edge computing. Looking at like we can expect several exciting advancement in edge computing. One key area is integration of AI and machine learning capabilities at the edge. Let's say you all know like ST microelectronics. They are taking like tiny ML into their microcontroller as well. The ML model is around like 300 KB, 500 KB. That's all. We can directly deploy that model in a edge device, and we can processing like computation and enabling that real-time analytics and decision making. The development of specialized edge AI chips will further improve the efficiency and performance. Additionally, the continued evaluation of 5G and emergence of 6G networks will provide even lower latency and higher data rates, enabling new applications and improving existing ones. Like the research and development efforts will drive further innovations. Here you can see the future applications like AI-powered edge devices and enhance the security protocols. Like in future, maybe they will use in the previous presentation also they discussed, right? Using the blockchain technology, there are many encryption algorithms are there for security wise. Next slide. Yeah. So we come to closing notes. So today we explored the transformative potential of edge computing in the context of 5G and 6G networks, we discussed the urgent need for edge computing, its advantages over traditional technologies, and various use cases across different sectors. We highlighted how edge computing can enhance the human habitats through applications in agriculture, healthcare, manufacturing, and power industries. And the future of edge computing looks promising with advancements in AI, machine learning, and quantum computing. Continued research and maybe development will drive further innovations, making edge computing even more integral to our daily lives. So the integration of 6G networks will bring unprecedented capabilities and enabling new applications and improving the existing one as well. So I encourage you to explore and adapt edge computing solutions in your respective fields. So stay informed about the latest developments and consider how edge computing can address your specific challenges and opportunities as well. So thank you for your attention and participation. So I now open the floor for any questions and discussions you have.
இங்க இருந்து பண்ணணும் எங்க பண்ணாங்க போர் செகண்ட் போர்ல participants, you have been unmuted. Please, you can have a short discussion with Mr. Sairam, right? He is online. Please, you can have a discussion before we wind up this second session. Dear participants, you can discuss with the expert.
Dear participants, you can interact with our resource person. He is in ready to answer for your queries. So you can unmute your mic and you can interact with our resource person, and you can put your queries in the chat box also.
சாமி நீ குழந்தைக்கு தள்ளிப்படு ஆசையா போயிரு கொஞ்சம்.
Please, participants, unmute your mics unnecessarily. Don't mute, right? Please mute your mic. Don't unnecessarily unmute your side. It disturbs the discussion. Please don't unmute unless you ask any question.
What is the major key factor differentiator cloud computing and
Your good name, please, ma'am.
My name is Padmala, sir.
Welcome, ma'am. Welcome. You can discuss with expert.
Sir, what is the major key factor differentiator cloud computing and edge computing, sir?
Yeah, Parimala, I'm audible.
Yes, sir.
What is the major key factor differentiator edge computing and cloud computing, sir?
Yeah, ma. In previous slide itself, I discussed, right? The major difference is like in cloud computing, whatever data we collecting, right? The processing, the computational things will happen in the cloud itself, the cloud server. But in edge computing, right? Whatever data is collected, it's just processed in the device itself. Like let's say if you have and deploy any sensors with integrated with some microcontrollers, there itself the processing will happen, like the computational process will happen, and there itself it will give that result as well. Whatever the action they required in the field, right? It will take that the action immediately based upon the inputs. So that's the major difference between that cloud computing and edge computing.
How do you differentiate the bandwidth of two, sir? Cloud and fog computing.
Bandwidth, like let's say in cloud computing, right? Depends upon that protocol we are using. Like let's say we are using in the Ethernet or any other fiber optic cables, right? Depends upon the bandwidth, the network congestion, the data rate we can define. But in the case of edge computing, it depends upon the processor speed. Let's say if you if you deploy any microcontroller, it having some certain operating speed, right, in the terms of megahertz or something, or if you deploy any high performance processors like NXP, some high performance application processor like A3, A53, something like that. Depends upon that process speed, the edge computing operating bandwidth we can define. And in our case, we are discussed about the 5G and 6G network, right? It's bandwidth around 100 gigahertz. So that's how it will derive.
Thank you, sir.
Really, madam, your really stimulating question has given a has given everyone the interest to learn about industry things. Sir has given a very right answer related to the difference between various mediums which we use depending on the bandwidth that depends on it. So other participants can please interact with him as much as interaction you have indicates as much as we have, right, been active in the online meeting. The wonderful chances we can utilize. Yes, sir, please, Mr. Kadu, Dr. NB Kadu.
Sorry, I have a question, sir.
Yes, Mr. Venkateswaran, sir. Kotandaraman, sir.
Sir,
Please, sir.
I want to know the difference between edge computing, cloud computing, and quantum computing. So where it is applied?
Yeah, Venkatesh, I'm audible.
Yes, sir. Yes, sir.
Yeah. Okay. Difference between edge computing and cloud computing, I hope I already answered the question. But between quantum computing is now only they are developed, right, by Google or some other chip manufacturers. I'm not sure about that quantum computing. It's still evolving. They're still working on. But I know the basic outline how quantum computing is working. Like in cloud computing and edge computing, if it process any data, it will take like either 0 or 1. But in quantum computing, if you take, it won't have any fixed values like 0 or 1. In the intermediate state also it can process in quantum computing. I hope I'll answer the question.
Any other participants wants to interact with the scientist? Yes, yes, the participants might have.
Sir, there is a one question in a
Chat.
chat box.
Okay.
How 6G enhances edge computing over 5G?
Okay, as we discussed, right, now in 5G, right, we are facing some latency during augmented reality. Now in our present organization also, right, for give better experience to our clients, right, we are giving some augmented reality services to our customer for visualizing the substations and to monitor the real-time data, right, to augmented reality. We give some user services, but by using the 5G we having some latency during that processing. But if you go with the 6G, right, the latency it will drastically reduce and the user will get the better experience by using those services. Yeah, I hope I answered that question.
Yes, sir. Very interesting, sir. I hope there is no more questions. Sir, really the session was very interesting. you have given everything about this new technology and the hardware and software requirements and the issues which is industry is facing on this particular topic. And we are very thankful to you, sir, having your busy schedule and few things, right? You have managed to be with us and presented your sessions very effectively, and participants enjoyed this session. Being a last date, right? We had a wonderful session with you. Thank you very much for joining with us, sir. Thank you once again. Thank you, sir, on behalf of St. Joseph College of Engineering, Department of ACE, and coordinator. And I am very thankful to you, sir. Thank you again, sir. 1 minute, sir. We will have a photo session, and then you can
Wind up. Yeah, sure.
wind up, please.
Yeah, sure.
All the participants are requested to unmute the camera. Please unmute your cameras for photo session. All the participants are requested to unmute the camera, please. Participants, please unmute your cameras. Then we will have a short break before we start the next session, please. Participants, please unmute your cameras. Thank you all. Please unmute your cameras. Thank you, participants. The next session will start exactly by 5. The next speaker will be in the on the online by 4:45. The next session will exactly started by expert. His profile reading will be started by 4:55.
Okay. Okay. Thank you all.
Thank
I'm
you,
signing
sir.
off. Thank you. Thank you.
Thank you very much, sir. Thank you. All the participants are requested to come again by 4:55.